Welcome to the molar mass and amount calculation lesson. So today we're going to be um, moving into starting to calculate different quantities of chemical reactions. Well, we're not going to react anything yet, but we're just going to calculate quantities of like one substance in a reaction. So, one compound here, one compound there, and then we can get into the reaction soon. I just wanted to just stop for a second and just kind of talk about this word. I know like I kept using nomenclature, and it took you guys a while to figure out what that was. So hopefully now you've heard it so many times that it's for naming different compounds. So the chemical formula, the chemical name. All right, so I'm going to be using stoichiometry a lot. We always call this whole unit stoichiometry, stoic for short. So it's just a fancy way to say it's the study of, calculating the mass, the amount of the different substances in a chemical reaction. Okay, so again, we're still moving ahead with chemical reactions, but we are going to be reporting things like, what mass did we place into the chemical reaction? What mass did we produce? How many, molecules of sodium chloride did we have to start the reaction? How many did we get in the end? And so just just make sure you use this word stoichiometry. So stoichiometry, a lot in your language as well. And just when I'm saying it as well, you'll understand what it is. Okay, but in general, that's all we're doing all the way through this unit. Okay, so we have a formula today. Little n equals little m, lowercase n, divided by capital M. So what the letters stand for, N, is the amount. So we looked at this the other day. So if I'm asking you for the amount of something, I want you to tell me how many moles you have. Okay. So for example, if you had a dozen eggs, there's 12 eggs, right? So if you have 1 mole of eggs, you have 6.02 times 10 to the 23 eggs. So you should understand what moles are. So today when I'm asking for n amount, I want to know how many moles. So you're going to say 3 moles, zero point 0.5 moles, 0.01 moles, and stuff like that. So that's what that part will be. M is mass. So again, like if you were to take the substance and put it on a scale and weigh it, you would have the mass of a substance. And then capital M we looked at the other day. This is the molar mass. Okay, so again, stack your units. So just, make sure you know the difference between these letters. I'm going to show you a way to today so that you don't have to use the formula. And so it's a method that I would like actually all of you to get to. But I know formulas are a little easier to kind of transition into a new concept with. So just again, be open to all the different ways I'm showing you today. I have an analogy box here too if you wanted to kind of refer back to this. So again, if I ask you for the amount of something, okay, so what amount of sodium do you have? You would respond by saying, I have 5 moles. Okay, so make sure you're writing your units as you go through so that it's really clear that you understand what you're trying to find, okay? And then when you're making therefore statements as well, we know, like if you're using the keywords that you need, the amount that I have is 5 moles of sodium, right? Then it clearly shows that you can communicate what you've found. The mass, okay, so again, grams, molar mass, it's grams per mole, okay, so stack up the units. All right, so we'll move right to an example here. So again, at first, we're just going to be analyzing, a substance, and then we'll get into reactions later on in this unit. So a chemist needs 4 grams of sodium hydroxide. Okay, so what amount of sodium hydroxide does the chemist need in moles? Okay, so we're going to start with the left side here and go through the formula method. And we're also going to use GRASP, which is something hopefully that you've seen in your previous science courses where you list all the things that you were given in the problem. You write down required, you write down what it is that you have to calculate. A, analyze is, do you need any formulas? Is there a plan on how to go about calculating it? S, solve, you would actually just go through and calculate. And then P, present your answer, write your final statement. Okay, so that's how we're going to go through here, and then I'll show you how to do unit analysis method next. Okay, so let's start off with the first one here. Given. So what information is given in this word problem? Okay, so we know that um, there's 4 grams of sodium hydroxide. So if it's grams, what letter? So if you're going to use the formula method, I always tell students to write down, you know, what letter is that 4 grams, okay, from the formula. So if you're looking at the formula here, we have N, M, and capital M, right? So grams. So again, that's why I want you to make sure you make the connection between mass is grams, amount is moles, okay? Molar mass is grams per mole. Because later on when you start to get to some other questions, it'll say what's the amount, and you should know exactly what letter, what it is that you have to find. So in this case here, 4 grams. Okay, so hopefully you know it's that little m. Okay, all right. So we are given the mass of 4 grams of sodium hydroxide. Okay, so what is it that you have to find? You have to find the amount. Okay, and then in moles. So amount is what letter? Amount is N. Okay, all right. We do have another piece of information, but we just have to kind of calculate our way to it. It is the molar mass. We always have the molar mass. If we know what substance we have, sodium hydroxide, we can always calculate the molar mass. Okay, so we're just going to use a periodic table and do that right now. So I'll just do that here really quick. Okay, so I went ahead and calculated the molar mass of sodium hydroxide. So again, for people that are still struggling with nomenclature, I see sodium here. So sodium, so I always write things in ions, right? So sodium, okay, is always a +1 charge. Hydroxide's on the back on the polyatomic table. It's OH minus, okay? So that will lead you to a compound, sodium hydroxide, like that. Okay, so then I went here and found so see that's capital M, molar mass, okay, of sodium hydroxide. So just make a little note. I know you guys are still getting comfortable with all these letters. So capital M is molar mass, okay? So the molar mass is sodium hydroxide. So if you take a look here, we have 1 sodium, 1 oxygen, 1 hydrogen, okay? So then I just went to the periodic table here. Okay, so sodium is right there, 22.99. Okay, oxygen is 16, and hydrogen is 1.01. Okay, all right. So now we have the molar mass, and we have the mass. Okay, so those are the 2 things that are given. Okay, so molar mass is always given, so you just gotta have to find it. Okay, and make sure you have all the digits. All right, n is the number that we have to find, which is the amount. So again, our analyze step is to go and look at the formula here, and we're going to use that formula. So we're going to N equals little m, so that's mass over molar mass. Okay, so again, that will be given to you. You just have to sometimes rearrange it. Sometimes you have to find capital M, sometimes you have to find little m, and so forth. Okay, so we need N. So it's already rearranged in the right order, so we're good. So now we're just going to solve. Solve just means start plugging everything in. So we have mass was 4 grams. And molar mass, okay, is 40. And then we divide that and we get, okay, and then you get 0.100 moles, okay? So if you were trying to figure out how to, to round it to there, what I want you to try to do as you go along, kind of look at the numbers, and this is just I know some of the students that took physics already, this isn't quite exactly the way you do it, but think of it like you look at the 2 numbers, and then the one that has, this one has 3 digits, this one has 4 digits, okay? So since this one has less, you're gonna have it so that there's 3 digits, so 1, 0, 0. The one at the 0 at the beginning doesn't count, okay? So anyway, so that's how you, it's called sig figs or sig digs, significant digits or significant figures, and that's how you're supposed to write it. So if you've already taken physics, keep doing that to practice your sig figs. But otherwise, I'm not going to pick on you too much in chemistry if you're not doing this perfectly, but try to get in that mode, I guess, if you're trying to figure that out, okay? So just kind of the one that has the fewest number of digits, 1, 2, 3, then you have 1, 2, 3 in your answer. Okay, so there we got our answer. This is the amount. Okay, so we're going to write that in our finals, our final statement here. Okay, present your answer. Use your key terms. Okay, so the therefore statement, therefore the amount of sodium hydroxide is 0.100 moles. Okay, so write your units, write all your digits, write the key term, amount. Okay, all right, I said I was going to show you a unit analysis method. I'm going to come back and show that, so that way if you want to, the people that want to look at those all together, we'll have all of the examples with this method together, okay? So I'll come back and do those. I'm just going to keep going here with the formula so we can practice the formulas, but then I want everyone to look at the unit analysis method. This is supposed to be the more efficient way of going about doing chemistry questions, physics questions, probably business questions as well. So anyway, so we'll get to there in a sec. We'll just go through with these ones here because formulas, you're used to those, you're used to plugging things in and so forth. Okay, so example 2, we have 1.50 moles of sodium hydroxide. Find the mass. Okay, so go through your grasp steps and write in all the things that you have. Okay, so again, you can analyze the problem. Okay, so 1.5 moles, right away from the units, moles. Whenever you have moles, you are finding the amount. The amount, in this case here, the letter is N, okay? Or, if it helps, write the word amount above it. Okay? Write them together until you get comfortable. Okay, in this case here, it says find the mass. Okay, so I don't need to write that one out. All right, so given the amount, so we're given the amount 1.5 moles. What's required? You need to find the mass. That's the question mark. Okay. All right, and as usual, we do have the molar mass of sodium hydroxide. Okay, I'm going to cheat here and I'm going to look up here. Okay, remember we found it already at the top here, so we're going to just use that. Okay, and yeah, you can do that in other questions too, but just you got to make sure that molar mass was calculated correct, because otherwise everything's going to be wrong. Okay, all right, so from there, so you have your amount, you have your molar mass, you need to find your mass. So an analyze step is, well, let's go look at our formula. Here it is. Okay, see, the formula is set up so it's equal to the finding the amount, but right now we don't have the amount, so we need to rearrange it so we find it. It's solved for M. Okay, so this is just a little bit of solving with math. You need to boot this molar mass out of there, so it multiplies with N, and you're left with M. So it'll look like this. It'll look like N times M equals little n. Okay, so that's the new formula. So we could turn it around. Okay, so we have mass is found by taking the amount times the molar mass. Okay, so it was divided by capital M. We're moving it over here, multiplying it over here. Okay, all right, so let's fill in the formula now. So we're going to calculate our M, and to do that, we're going to plug in 1.5 moles. Okay, and multiply by the molar mass. Okay, so the previous example was a little tricky to show the units canceling, but see how this is the reason why I want you to stack it. So you have 1.5 moles at the top here, or beside, and then beside 4 grams, and then the mole goes underneath, right? It's gram per mole. So if you can see here, you can cancel anything that's at the top and the bottom of a fraction. So you can cancel them out, okay? All right, so that leaves with just grams, which makes sense because our mass has to be in grams. Okay, so go through, calculate this out. Okay, and then our calculator gave us exactly this, okay? But if we're looking at our significant digits here, so we have 3 here, 4 here, so we just need 3, so I'm just going to go dot grams like that. Again, don't stress if you're not comfortable with sig figs. Yeah, just kind of use the rule of thumb, like the numbers when you're calculating them, the one with the fewest number of digits, that's what's going to determine how many digits your answer should have. Okay, so 1, 2, 3 digits. Okay, so 60.0 grams. All right, so our therefore statement. Okay, so again, you got to use your key term. What is it that you had to find? Mass. Okay, so therefore the mass of sodium hydroxide. So I'm okay if you guys just write the formula instead of writing the name out. The mass of sodium hydroxide is 60 grams. And I don't care what tense it is. If you said was 60 grams, that's fine too. Okay. All right, so we'll continue on to the next one here. All right, so we have a manufacturer, according to the manufacturer, typical cola can has 40 grams, 40.0 grams of sucrose. Okay, there's the formula for sucrose. I want you to calculate the amount of sucrose in 40 grams. Okay, so now that you've read through the problem carefully, I want you to go through and identify all the stuff that you have. So you have 40 grams here, so just write the letter, maybe write the word with it as well until you get the letter memorized. You have the formula, calculate the amount. Okay, so this word here is N, amount. And again, that's me asking you, how many moles of it do you have? Okay, all right, so given the mass, okay, and then you need to find the amount. So you're given the mass, you need to find the amount. All right, and like I said, you always have the molar mass. You got the formula, you have the molar mass. Okay, here's the sucrose formula. All right, so I'm going to just stop and just quickly calculate that. Okay, so I went ahead and calculated the molar mass of sucrose. So again, here is the formula. So I'm looking and seeing that there's 12 carbon, 22 hydrogens, and 11 oxygens. So, okay, so I went to the periodic table, and if you take a look here, carbon is 12.01, so that's why I'm multiplying 12 carbons times 12.01. Hydrogen's 1.01, and oxygen is 16. Okay, so again, that's from last day. If you're still shaky with this, go back and practice some more questions. All right, I didn't even calculate them out. I just kind of went through and calculated them all together. I didn't have enough space, but again, if you need more space, just give yourself lots of space on paper for this whole unit, okay? All right, so here is the molar mass of sucrose. So those are the two things given, mass and molar mass. We need to calculate the amount. Okay, so we need a formula here. Okay, so N is always, amount is always mass over molar mass. Kind of keep just saying those in your head so then you get the letters memorized, okay? Otherwise, if it helps, just write amount equals mass over molar mass in words. All right, from there, let's solve it. Let's plug everything in that we know. So 40 grams divided by 342.34 grams per mole. I'm going to show you in a second when this is done how to kind of figure out the unit here, but just it helps that if you just memorize them, then you're good too. Okay, so this comes out to, let's go 3 digits. Okay, so I know that amount, the units are moles, so 0.117 moles. So therefore, what's the key word? Amount, okay? The amount. So sometimes I might find the moles of the substance, okay? So I could say that as well, but amount is the key word as well. Okay, the amount of sucrose, okay, was 0.117 moles. Okay, all right. You can skip ahead to the next example, but if you're curious as to how, like back up here, I showed you how like when the units were kind of right beside each other and we had it stacked up, how they would cross out nicely. Here it's a little trickier because it's like you have grams and then you have divided by grams and then you have it divided by moles. So I'm going to just show you, it's kind of related to fractions of math, how those units cancel out. So right now, without looking at the numbers, we have grams divided by grams per mole. Okay, so I want you to, so again, if you just want to memorize the unit, that's great. But otherwise, if you want to figure out how does this become just moles, okay? All right, so it's like you taking a number. So if I just do an aside here, if you take a number like 2 and you need to divide by 2 and you need to divide by 4 over 5, okay? So this is what it would look like right now. You have to take 2 and divide by 4 over 5. So you've learned in math that you don't divide fractions, you multiply the reciprocal, like you flip this one, okay? And then it's easier to multiply. So it's the same idea here. You can't divide these. You're going to multiply. I'll just put a dot for multiply. You're going to flip this fraction, okay? So actually here, why don't I just write it like this before we flip it? So right now we have grams divided by grams per mole, okay? So what you're going to do, you can't divide fractions, so you're going to multiply, you flip the other one, okay? So when you do that, see how grams goes to the bottom, and now you can cancel these out, okay? And then you have just moles, okay? So here's just a way for you to understand, I guess, why grams divided by grams per mole becomes just moles. Okay, so that's what's happening with those units. All right, again, not going to test you on that, but if you were just curious, it might make better sense when you're kind of going through the unit analysis method, but for now, we're going to keep going with the formulas here. All right, let's go to the next one here. So we have a liter of human blood, okay? All right, this is the last example. All right, so analyze the question and then make a decision on what method and what approach you need here. Okay, so human blood typically contains 0.0000040 moles of glucose. Calculate the mass of this amount of glucose. So again, just kind of like stay calm. I know like amounts being thrown at you, mass is being thrown at you, but think about what did they want you to do? Find the mass, okay, of this amount. So again, you see moles there, so you should know, oh, that's my letter N. N is amount. Okay, so amount, moles, N, all the same. All right, and this is mass, M, okay? And that's grams. All right, so let's go through, fill this in. All right, so that has that, and then the mass is what we have to find, and as usual, we do have the molar mass, so I'm just going to calculate that. Our grasp steps, the molar mass is always, it's not directly given to you, but it is one thing that you can always find, so that's always one of the givens, and then one of the other values literally in the question, okay? So kind of go through an approach and go, oh, wait, I don't have the M. Yes, you do. You do have the capital M, okay? All right, but we do need to find the little m. So let's go through here and I'll analyze the equation that we need to find. So again, we have a default equation. So this is the format. I'll always give it to you, and you have to rearrange it though. Okay, so again, you need to find little m, which is mass. So you got to move this big capital M out of there. Right now it's divided. You need to move it over, and then it becomes multiplied with the n that's already over there, okay? Again, hopefully rearranging formulas, it's not bad, okay, for you. All right, so from there, let's calculate it, fill it out. Okay, so we have the mass is the amount in moles. How many of those there? Okay, and the molar mass in grams per mole. Okay, here's another one where they're right beside each other, and it's great because, you know, you can just take the mole, cancel them out, okay? And it's kind of like if you forget to during a test, oh, I can't remember what units mass is, right? Uh, I'm sure you can remember, but if you can't, then you just slash them out and go, oh, it should be grams left, grams. Okay, and the final answer is okay, so again, if you're wondering, how did I know to round there? Again, don't stress about rounding. Just give me, just add some digits here, at least, 3 or 4 every time. You're just looking at, with this first digit number here, you have, okay, so you don't count leading zeros. So these first 3 zeros, you don't count them, but then you have, you will count the zeros that come after. Okay, so we have 4, 0, that's 2 digits. This one here, we have, I know we have a 0 in the middle, but we counted, but we have 1, 2, 3, 4, 5 digits. Okay, so 2 digits, so I rounded to 2 digits here, and my therefore statement, therefore the, what's my keyword? Mass, okay? The mass of glucose. The mass of glucose, oops, is 0.72 grams. Okay, all right, so again, don't forget units, don't forget the keyword. Okay, so I'm going to show you the unit analysis method. So I'm going to go back to the top and do these same questions again. Please continue to watch the video. I want you to learn this method as well. And then once you see the whole thing, make a decision which method do you prefer, okay? But ideally, we would like you to move to the unit analysis method. But again, it's all about everyone's different. If this formula way works better for you, or if you find a different way for it to work, then we want you to do whatever is best for you, okay? But this method will help you though with like other classes. Like it's what a lot of teachers will use in university, and use it a lot in physics as well if you're also taking physics. So it's good. All right. Okay, so if you're wondering where I went in the sheet, I scrolled back up to the top. Okay, so we went down the left side using the formula method. So given a formula, can you calculate out the values that are missing? Okay. For the unit analysis method, that's the right side here. We're going to go through, and as we're going through, just keep in mind the goal here is to try to cancel out the units. We're not going to try to memorize a formula and plug things in places. We're just going to use the information that we have, and then we're going to our goal is to try to cancel out the units that we have so that we can figure out what's left, and then we'll get to the answer, okay? All right, so again, I know I've written all over the problem here, but I want you to analyze it like there's no writing on here, or maybe here I can probably erase. Oh no, I'll leave it. I'll leave it now, for now. So go through and make a decision. Okay, yes, I do have mass, right? Yes, I have mass. So you could just write that down. I have mass. So right now, just ignore this part here. I'm going to show you what to do there. So you have mass. So just write it down, 4 grams. Okay. We're trying to get to amount in moles. Okay. So we need to get an answer in moles. So the other thing that we are given, so I guess starting this question off, you should still do the given part of the formula method. You also know that you have the molar mass of sodium hydroxide. So I'm just going to go and write that right beside. Okay, so I took the mass and I wrote the molar mass right beside it. So hopefully you can see here right now that you know how I was showing you earlier in the video how you were canceling out things. Like I could probably show you right up here. See how like there was moles here, and then the moles was underneath. It was below the fraction, so you can cancel things out when you see that. So that's our goal. So right now, if you're taking a look here, see how grams are the common units here? We have two of them, and it'd be nice, we want to try to get rid of the ones that we have doubles of, okay? But right now, I can't do that because grams and grams are both at the top of a fraction. Because like if you think about it, it's like this one here, it's like any numbers in math, there's always a 1 underneath. So grams is at the top of the fraction for both of them. So this is an issue. So what we're going to do here is we're going to, because our goal here is to get amount, we need to get moles to the top. So I'm not going to flip this one, but I'm going to flip the second one here. So I'll just rewrite it. Okay, so this is a no. Okay, don't do this. So I'm going to write it again. So I have 4 grams. Okay, and remember I can draw a line right underneath here, like whoops, like that. So it's like 40 grams over 1 mole. Okay, so so what we can do is we flip it. Okay, so if you want, you can think of it as 40 grams over 1 mole. We're going to flip it. Okay, and then 40 grams goes to the bottom. Okay, so this is the unit analysis method because we're trying to get it so that the units will cancel out. All right, so once we do that, we can cancel out the grams. Okay, and then what happens here, so I can extend the line here. What you have is you have an equation already set up, 4 times 1 divided by 40. So if you do that, 4 times 1 divided by 40, you will get 0.1 moles, like that. Okay, oh, and then we want to use our digits here. There you go. Okay, so again, you still needed to find the molar mass, so you would do this step here, but you found what you needed. You didn't have to find, write the formula, plug it all in, and so forth. You were just kind of, so the main thing is you don't have to memorize the formula. You just kind of stack them up like this so that the units will cancel out, and it'll get you to the answer that you need. Okay, and then you write your therefore statement. Okay, all right, so it's a little uncomfortable at first. So remember, this one worked. Okay, the way that this was lined up didn't work. Okay, but this one worked. So let's just try another one, and then you'll see that it's just a matter of, you don't have to memorize the formulas. You should be able to put them together, flip some, and then get it to the answer. Okay, get it to the calculation that you need without memorizing a formula, even though I'll give you the formula. Okay, all right, here's the next one. Example 2, we have 1.5 moles of sodium hydroxide. Find the mass. Okay, so again, just write out the information that you're given. 1.5 moles. Okay, and then I also have the molar mass, so I'm just going to write that right beside. Okay, and then from there, so again, you can extend the line here for the molar mass, and then if you can see here right away, you're noticing, oh, everything is stacked up perfectly so that I can cancel out the units, okay? Because right now we have 2 moles. We want to get rid of the moles, okay? Because we want to get mass, so we want grams left. So this is right. So we're going to go through, calculate it out. Okay, so what this means is when they're right beside each other like this, it's like you going 1.5 times 40 grams, okay? Ends up being 60 grams, like that. The moles are gone. And then you write your therefore statement. So again, people, you have to give this one a chance, but you'll find that it's really smooth and it's efficient, and there's a little bit less writing and formula, because here on this side you have to rearrange the formula, plug it in, and so forth. Okay, so it's almost like you go from the given right to the solve step really quick. Okay, all right, let's try the next one. All right, so what were we given here? We were given the mass, so 40 grams. Okay, And another advantage of this method, you don't have to sit there and think of all the letters like that's little m, that's capital N, little n. Okay, some people don't like that method. So, all right, so we are given mass. We also again can find the molar mass. So I'm just you'll get better and better at this. Like you'll know after a while. Like I can't write those right beside each other. Okay, so once you see it written beside, you're like, oh no, grams and grams will not cancel out. So okay, so this is no, not this way. All right, so try it again. All right, I got to stack these. So again, it's like you just flip it. Okay, so again, I know a lot of people bugs them if you just flip it and there's nothing here. So you can put one there. Okay, and then put this underneath. Okay, so remember when we're writing it right beside, we're trying to multiply here. Then you can see, oh, grams and grams will cancel out. Cancel, cancel. Okay, and again, you're like I keep hinting, we're going to get to more and more elaborate type of calculations that you're going to find that when you can set it up really quickly like this and kind of cancel stuff out, it's going to be nice because it'd be like slash, 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 all the way across the page, slashing out several units to get to the unit that you need because you need to calculate the amount, which is the moles. And then you write your final statement. Okay. So again, if you're like, I get the formula way, it makes sense, I'm not going to do it this way, I want you to still try to do it the unit analysis method, okay? I want you to learn this and keep giving it a chance. I know some teachers will say, nope, you're just using the unit analysis method, nothing else. But I want you to have like, you should always have multiple ways to try to do something so that you have a backup plan in case one way is not working, you can double check. All right, keep going here. The human blood example. All right, so we have this number. Okay, so it's in moles, and then we have molar mass. Okay, so you're seeing here that, okay, so again, you are able to cancel out the moles here. So it's already stacked up the way that you need it to be stacked up. Okay, you don't need to flip the second one. And you're going to get to 0.72 grams. Okay, so again, moles cancel out, grams is left, so you're just taking 0.004, multiplying it by 180.18. Right, and then write your final statement. Don't forget your final statement. Don't forget your units. All right, so hopefully this is convincing some of you to switch to this method. It's a little quicker. So again, you would still do the molar mass part, but then you just do this part here and you're done. Okay, all right. So I'm gonna post some worksheets, practice questions for you to try. It's really important in this unit that every lesson that I provide you, you need to practice it, learn it, so you're comfortable for the next stuff because like everything in this unit is very cumulative, so you have to know how to do molar mass. So the next day I can use molar mass to do something else. The next day, like we learned about amount and we've learned about mass and molar mass together. The next day after that, we're going to be counting literally how many, like if there's a mass of 5 grams of something, how many like sodium chloride compounds are in that mass. Okay, so we're going to learn about entities. So it all kind of keeps building all the way through the unit. So that's why please keep up, do the work, practice it so you're not shaky at going into the next concept. Okay. All right. So, and with this one, please learn both methods. Please, please, please. Okay. And here, I'm going to show you the formula sheet here so that another way to kind of get comfortable learning the methods here. Okay, so I just jumped to the formula sheet. This is on the back of your periodic table package. So if you're taking a look here, this is a lot of the stuff in here, like along this line of stuff. This is what we're going to be doing in within this unit, and then some of these ones that branch off will be the next couple of units after. Right now, what you did today, or like last day, you figured out what molar mass was and how to calculate that. Today we looked at the relationship between mass, molar mass, and moles. Okay, so um, because you're going to learn a lot of different calculations, this sheet here is to kind of help you focus and go, oh yeah, if I need to get back to mass, I need to use molar mass somehow. Okay, or if I need to get from mass to moles, I need to use molar mass somehow. Um, so I've had students in the past just memorize what they need to do from um, to get from mass to moles, and then back from moles to mass. Okay, so we're just looking at our formula sheet. This is on the back of our periodic table. So again, like we were looking at solubility tables, we were looking at the activity series before. So there's just all these bubbles and squares up here that or rectangles that I want to show you. So again, if you are just needing a little bit of a hint, if you kind of can't remember during an assessment, oh, which way do things go here? So if you take a look here, if you go from moles to mass or mass to moles, you need to use molar mass somehow. So I've had students, they didn't feel that great about formulas. The unit analysis method was okay, but they didn't like it. So sometimes they just memorized it like this with the rectangles like that. So mass and moles. So basically, we know to go this way. So we'll make it around here. So if we know to go this way, okay, when we want to go from mass to moles, we're going to divide the molar mass, right? So if you think about it as, like if you were doing the formulas here, so you had mass divided by molar mass, gave you moles. So some students looked at it like, oh, when we go that way, we divide. Okay, when we go back this way, we multiply. So if you needed moles, if you need to get mass was always the moles amounts multiplied by the molar mass. So they would memorize it this way. So that's another way for you to go about, getting these calculated out. Okay, so that's why I have here at the bottom, like if you want, you can memorize this so that, when you go this way, you will, okay, divide. When you go back this way, you multiply, okay? Otherwise, like some people prefer having multiply at the top, so if you wanted to do it that way, so if you were going this way, right, you would multiply, but if you go this way, you would divide. Okay, so either way, just kind of know, okay, so mass to moles, you need to divide. Moles to mass, you multiply. Okay, so just kind of find a system that works for you. But again, yeah, like this is you memorizing letters to figure it out. Formula method, you have to memorize, so not memorize, but you have to kind of look at this and look at the formula and rearrange it sometimes. Here, this is on the back of your formula sheet, so it might jog your memory as well, like what to do. The unit analysis method here, again, you stack them up and divide out the units and so forth. So again, find one method that works and then just go with it, but have all of these other ones as a backup plan so that you can, just get really confident. Okay, so I'm going to give you a handout and then practice some questions in your textbook as well.